Multiplying radicals. You guys have actually been doing this when you simplify them. You don't write this down. But if I said, if I asked you to simplify that, what would you break it down to? How would you break it down if I asked you to simplify it? Which one do I usually try to write first? So root 4 times root 6. So you find the highest perfect square, and then you figure out, okay, 4 times what is 24? Because root 4 times root 6 is root 24. That's really all multiplying is. Right? So you guys have actually been doing it. When you take some radical, could be any root, nth root of a, and you multiply it by the same index, but it could be a different number underneath, it's just equal to a single radical, and then you multiply the two numbers underneath together. So root 2 times root 7 is root 14. Root 5 times root 8 is root 40. Cube root 2 times cube root 8 is cube root 16. Okay? Square root 2 times cube root 11, you can't do. They have to be the same roots. Okay? And just something to note, sometimes it is easier to simplify one or more of the radicals before you multiply them. Before multiplying. And we're going to see an example of that. Okay, so what's root 6 times root 10? Yeah. But remember, like when you guys did fraction questions, after you were done, you always had to make sure you reduced. Like with radicals, you got to make sure that they're simplified. Is there a perfect square that I can simplify this one with? That goes into 60.
Yes.
There is. You tell me. 4 and 15, I heard. So it becomes 2 root 15. That's it. So just multiply and then simplify if you can after. So here, this is the same as 1 root 3 times 4 root 15. So we can multiply the non-radicals. What's 1 times 4? And then we can multiply that by the multiplication of these two. Root 45. And now I check to see if I can simplify. I think I heard it. 9 and 5. Which becomes 4 times 3 root 5. Well, I can do the 4 times 3 and get 12 root 5. Remember, you can multiply non-radicals together, like 4 times 9. You can multiply radicals together, like root 4 times root 9. But you can't multiply a non-radical by a radical into a single thing. Like 4 times root 9 is just 4 root 9. You can't go any simpler. What would this one be when you multiply it? Negative 6 root 40. That can be simplified. Or 10, root 4, root 10. Which becomes negative 6 times 2 root 10, which becomes negative 12 root 10. Yeah, exactly. Wow. That is sure going to get you a big one under the radical, which could be very difficult to simplify to find the highest perfect square. But remember that note that I made at the beginning? Let's simplify first. Well, I can't simplify 2 root 7. There's no perfect square that goes into 7. But how about 75? Yeah, root 25 times root 3, which becomes 2 root 7 times 4 times 5 root 3, which becomes 2 root 7 times 20 root 3. Still have to multiply, but boy, these numbers are a lot easier now. Okay. Yep. 40 root 21. That's the answer, because you can't multiply a non-radical and a radical into a single thing. Okay. How about this next one? What would it be? What do you think the answer would be when I multiply these two? Not quite. You haven't said it all. Cube root 54, which can be simplified, but now you've got to think of your perfect cubes, not your perfect squares. There is a perfect cube that goes into 54. Does 8 go into 54? Well, you'll have to check and let me know. What's that? 6 what? What is?
Okay. I was just thinking in my head.
Okay.
27.
27. How many times? 2.
Wow.
And what is the cube root of 27? You should know this. 3. And you can't do anything with the other one, so it's cube root 2. Oh, this one's got some variables and exponents. Okay, let's multiply. No, because we're multiplying first, right? When we simplify, we split them. Negative 8. Square root. To the 4th, because remember, y is the same as y to the 1st. Good. Now, simplify, but remember when we have numbers and exponents, we split. 22 square root y to the fourth. And then we see what we can do with each one. Can you do anything with root 22? Is there a perfect square that goes into it? 22. 2 is not a perfect square. 1 goes into it, but then it doesn't change it. It just gets back to root 22. And then you start all over again. You never use. No. So you leave it. What about square root y to the fourth? Can I do it exactly? Or do I have to find that? Yes, y squared. It's exactly y squared. You don't have to split it up. But then what do we have to do? We have to rearrange the order.
Negative b plus.
And that.
So you can rearrange the order of that question. You can completely wrong.
No, it would not be completely wrong. I would probably give you a communication error.
Yeah, those get you.
Yeah, those darn things. Gosh, golly. Okay. Ooh, what do we do here?
Not all of
What do you think we do here? What's that?
I think we times 7 and 5.
Right. Remember, what if I gave you this?
Then you put the 2 to everything.
You multiply the 2 by everything inside. Same thing. So it's going to be 7 root 3 times 5 root 5 plus 7 root 3 times 6 root 3. Good.
Fill in fields.
You did. Okay, so and now we just do each multiplication. 7 times 5? Root 3 times root 5? Root 15. Okay, so when I multiply that, those 2 first ones, I get this. Plus, what do I get? 42 root 9.
Oh, it's easier than it looks.
Well, hang on, we're not done yet. Because we have to look at simplifying. Can I do anything with the first one?
No.
No. There's nothing you can do. No perfect square goes into 15. You can't reduce it. How about root 9? Don't overthink this. It's just 42 times 3. You don't find the highest perfect square because 9 is a perfect square. This is exactly 3. So it's 42 times 3, which means we get 35 root 15 plus whatever 42 times 3 is. 126. Well done.
We have to rearrange.
Why?
No rearranging.
No, that's only if everything's getting multiplied. There's a plus in there.
So you only
There's a big difference between this and this times this.
we were multiplying.
No, we finished our multiplying and then we're adding. We did our multiplying here.
Don't we have to rearrange?
No, because there's an addition sign between them.
Oh.
You only rearrange if it's all multiplication. When I multiply these two, what do I get?
Negative 6, 22,
Negative 6 root 22.
8,
Give me the sign. Plus 8 root 12. Can't do anything with the first one, but I can do something with the next one. And I'm going to change the way I show this. I'm just going to, off to the side here, go root 4 times root 3, and I'm going to put 2 root 3 right in here. Because it saves me a step.
Additionally,
Okay, so I'm just going to go like this, like this. You don't even, I mean, you guys will do so many of these that you should get to the point where you're doing several of them in your head. Okay, like root 28, 2 root 7. Because you'll think in your head root 4 times root 7, which is 2 root 7. Some of the bigger ones you may have to show your work, but some of the smaller ones you'll start getting them quickly and you'll be able to do them mentally. So that gives us negative 6 root 22 plus 16 root 3. Oh, these darn letters again. Oh, these darn letters again. Okay, so how many multiplications? This time 3. 2 root K4.
yes.
Root K to the 4th. We're not playing Battleship. You said K4. That's always your comeback line. That's always your go-to line when you don't know what to say. Yeah, whatever. Minus 2 root K to the 2nd. Nice. It was. Plus root K. All right, let's look at each one. Square root of K to the 4th. Can I do it exactly, or do I have to find the highest perfect square? So K to the 2nd. Minus 2 times, I can also do the square root of K squared exactly. I cannot do anything to this. Are any of these 3 like terms? Do they have the exact same variables and exponents? No. This has got a square, this has got a 1. Remember last year we learned that the square root of K is actually K to the 1/2. Okay? So you can't combine.
Yeah.
So I'm going to stop there because I want you guys to get a little bit of practice with this.